constraints to it. 4 if you want to consider the fact that you're, well, 5 if you want to consider that you're making doll clothes for a living. That's kind of weird. So it's really not the issue. You have what? You have no more than 30 hours available, and you can make at most 15. Those are your only 2 constraints. So many outfits add up to 15, and so many hours add up to 30. And then your object, I believe, was to make a profit. That's a really straightforward one. A couple intercepts, got to be first quadrant problem. A couple intercepts, crisscross, and you're done. Sir?
I came up with this answer to 15.
Is it that one? I think it's, you might want to double check, or you might have substituted something incorrect in the profit part. Or watch how you labeled your axes. Okay, watch how you labeled your axes. Those might have been backwards also. So, end of today, I have the table for you to finish the bottom one. It actually is really easy when you see it in a table form, because it's like really easy to do table form. And then we'll have, I think I've got like 6 other problems for you, which aren't word problems. Well, 2 of them aren't, but they're easy. We okay with that setup on that doll one then? Something plus something equals less than or equal to 30. Something plus something is less than or equal to 15, or at most 15. Because those are your 2 constraints. Work off that and it falls right into place real quick. So let's do this then. I want to look at systems with 3 variables. It is the exact same thing as systems with 2 variables, only 3. That's it. That's all it is. Okay? And to be quite honest with you, it is relatively simple to work with. The mistakes that people make is when they write down the problems, they miss a negative sign. Or when you're adding things together, you think that 2 plus 3 is 6.
You can add those together right there and get rid of y and z.
And you can start going through a lot of stuff. Yes, there are.
Oh wait, no, I'm just kidding.
Let me undo this first, and we'll worry about it in a little bit. I don't think it's going to take me forever to get through all this. Okay. So the reason that we want to talk about this systems with 3 variables is that when we get into working with parabolas next week, when we look at parabolas, parabolas are going to become a set of points that create a curve via a quadratic equation. And we've all done that. It's not anything crazy. What's going to be new a little bit with the algebra 2 is that eventually I can give you guys 3 ordered pairs that lie within the parabola. And you're going to be able to give me the equation of the parabola by using a system of equations. Okay. So what I need to do is just kind of review with you guys, how do you work with a system of equations that have more than 2 variables? That's really all there is to it. Now, your objective, obviously, like you were saying, is to eliminate stuff and try to break it down into a smaller chunk. A lot of times what you want to do is use one equation as, I don't know what you want to call it, maybe like as a pivot to eliminate a variable in 2 others. Now, you were saying go ahead and add 2 of them together right away and you'd eliminate both x and y.
Y and z.
I'm sorry, I'm looking at them and I called it x and y, but yeah, I'm looking at eliminating y and z. Now, if I do that, if we add those 2 together, I was thinking of doing something different. Let's see what happens.
Let's do what you want.
No, it's okay. If we add those 2 together, we wind up with 6x is 18. So x would be, what was that, 3? Okay. And then you could put the 3 into all of these. So then you have a 6, a 3, and a 12. Moving stuff around, then you have negative y plus z is subtracted over negative 2. Y minus z is 2. But then when I add these guys together,
So y is z plus 2. I mean,
it all just,
huh?
what?
Where did you get?
Wait, why minus Z?
I took,
No, I understand everything, but.
I subtracted 12 to here, and I got y minus z equals 2.
Does that mean like any solution?
If I took 6, brought it over here, I get negative y plus z is negative 2. So I rewrote into here. And then all of a sudden you get with 0 equals 0, everything's eliminated out. It's probably not the way to go. Okay? So when you saw,
I get like everything like you did like the like x equals 3 and then like substituting it back in.
guys, please.
And then substituting it back in, but then when you like and then y minus z equals 2, why is that 0 equals 2?
If you add these all together then all of a sudden everything's gone. I got rid of 3 variables, I went down to 2 variables, so I still have a system of equations.
Oh,
But you try to cancel it
oh,
out.
because
I'm trying to solve for-
the other one up there. Okay.
I'm trying to solve for x, I'm trying to solve for each one of the 3 variables. Now, by doing what you had there, by eliminating 2 variables right off the bat, all of a sudden everything goes away. That's not kind of the objective to this. What you want to try and do is you want to, let me just do this. When you are working with 3 variable systems, you want to try and look at one of the equations to use it as I'm going to call it as a pivot to eliminate just one variable in the other 2. Okay. So that's when I start looking for opposite signs and things like that. What I would probably do here is I would probably take the first equation and add it to the second equation, and take the first equation and add it to the third equation, and by doing that, which variable would I eliminate? Z. And then I can solve the system of equations via 2 variables and then work my way backwards to it. Okay. That's the idea of what we're looking at. So I'm going to take first equation, 2x minus y plus z is 4. And I'm going to add it to the second equation, x plus 3y minus z equals 11. I'm going to add all of these parts together. Bless you. Sorry. When I add those parts together, the z's drop out. So I wind up with a new equation, new system equation here. I have 3x plus 2y is 15. Everybody okay with that? I'm going to do the exact same thing then with the first equation and the fourth. We're not that far yet. Or will we? You can do 4x4s, 5x5s. Oh yeah, that's awesome. Just wait. It's great. Do the same thing. 2x minus y plus z is 4. And then I have 4x plus y minus z is 14.
So you get a success equals.
Add them together, we get the 6x is the 18, which means now we had this earlier. We have the x equals 3, but notice now.
And then you substitute it back into that one?
Correct. But by doing it the way you were saying the first time, well, let's just add those 2 equations together, eliminate them both. You eliminated 2 variables, and you were able to go back and substitute stuff through. Okay. So
you think you should eliminate one variable at a time?
yep. Now, this case, we got kind of lucky with this one, where you wound up with the y's dropped out as well. All right. So we got okay with that one. Sometimes you might have 6x, another y, then you'd have to solve the system over here via elimination or substitution or one of those other methods from the other day. This one, you get an x equals 3.
I got y equals 3.
So then we have 9 plus 2y is 15. So 2y 6, so we have y is 3. So we have 3, 3, and then we have to figure out z still. Yay!
Plug them both in.
Yeah. So we go back up to the, we can use any one of those, might as well just use the top one. We had, what was it, 2 times 3 minus 3 plus something is 4. What's Z? 1. 6 minus 3.
Oh, got it.
3 plus 1 is 4. So you wind up with a, actually, I wouldn't say it's an order. It's not an ordered pair. It's an ordered triple. This is a point in 3-dimensional space. This is a point where you have an x, y, and z axis. You've never heard of 3-dimensional space before? You live in it every day. When you write out your ordered pairs for your solution set, like we had before, you know how we write a little x, y? What do you think this is going to look like? X, Y, Z. That's it. So your system would, your answer would be 3, 3, 1. Now, you know how when we when this carpenter eliminated those 2 variables right away, and we had 0, 0. Notice we have 3 and 3 here. The reason why it was 0, 0 is because both those x and y's would be the same. It's just dumb luck happens every once in a while. You want to see what that looks like graphed? So you have your x, y, and z axis. Yeah, it's up, it's left, right, up, and out. Some books go, some people go x, y, whatever. We'll just do it like we do. I'll show you what it kind of looks like normally. We don't normally graph 3-dimensional. We used to. There really is no reason to do it. So 3, 3. So over 3 over 3. Then we got to go up 1. So it would be here. Then we got to float it. I think it comes to here. So it's like here, I think. It's been so long since I've floated 3-dimensional. So it's, here it is. I just made that up. It's like I'm graphing an imaginary number right now. It's purple. Did you want a quiz instead, or do you just want to listen to bad jokes?
Bad jokes.
And I'm sorry, you've got like 2 years of this now, and it's just, I feel bad for you. Maybe I'll teach pre-comp next year again, and you can get 3 years. Wouldn't that be sweet? You're like, I'm transferring. Hey, here's the table. I'll give you a copy of it. Oh, there it is. Good. Let's try this one.
By yourself.
Oh, we'll write it down. We'll go through it again, see if we can do it. I'm not going to lie. I'm trying to give you problems tonight that will give you integer values for solutions. So if you start getting really crummy numbers, you done goofed. Just so you know. You could get really crummy numbers to halves and thirds and all that kind of stuff, but for tonight, just to get you kind of started a little bit, make sure you guys get numbers that make sense, like 4, -3. But if you get like 7,200 over 113, you might want to recheck what you did. One thing that happens a lot with these problems, when you write them down, looking toward the book, going to your page, going back to the book, going back to the page, or sorry, looking to the screen, going to your page, looking back to the screen, back to the page, a lot of times you will write down numbers from a different problem. It happens all the time.
Oh, I
Okay.
did it all.
Yeah, it's,
They do that? Is that what you said?
you're like, wait, why is my answer -74 over 806?
Is it like the cutoff where you always like add the first and second together?
It Totally depends on the equation, totally depends on how you want to set it up. Because you have all those different means of doing things, you can eliminate them right away, or you can do some sort of linear combination to work with it. It's totally up to you as to which method you want to use. Whenever I do these things, I look for ones that have opposite signs. If in this case here, I'm drawn to this secondary equation because I have a negative y. I can use that as a scalar to eliminate the 2y above it. I can use this as a scalar to eliminate the 3y below it by only having to multiply one equation out. Now, it would be great if this 3y in the third equation was positive, then I wouldn't have to worry about subtraction at all. But I can manipulate that if I want to multiply it by something else. But it is completely, totally up to you where you want to start. Personally, I look for things that have coefficients of 1, and if they have opposite signs of other things. The way that my mind thinks, Lord knows it's weird, it likes that method because it's a little less messy. So, oops. How do you want to start?
First and second.
First and second, okay. So, yes ma'am.
Never mind, I was just gonna, never mind.
I'm going to take the second equation, multiply it by 2, I'm going to write that first. So I have 4x minus 2y plus 6z is 8.
Oh, that's what I'm
And the next one is 3x plus 2y, 4z is 11. And I'm going to add these guys together. That eliminates the y value. 7x. And I'll do the same thing to eliminate the y value of the third equation. I'll multiply the top of the first equation then by -3. Okay, multiply this one now by -3. And if I do that, I get -6x plus 3y minus 9z is -12. 5x plus 3y. You guys see what I mean? Probably right away about being careful with signs and stuff. It is so easy to go through all the work and done goof one thing, and then fall into the black hole of despair. Add these guys together. -1x minus 4z is -13.
You multiply -2 times 2x minus y plus 3 equals 4, right?
For which one?
For the one up top on the right.
On the first one, I just multiplied it by multiplied that one just by +2. I took the second equation, multiplied it by +2, and added to the first equation.
How'd you get next? How'd you get? Oh, I'm looking at the.
So now we have -1x minus 4z and -13. What do you want to do?
Use substitution, silly, it's quicker.
What's that?
Substitution,
Fine.
really, it's quicker.
Use substitution.
Divide
Here,
by -1.
You don't even have to do that. Here's what I'm going to do. I'm going to add x. I'm going to add 13. 13 minus 4z is x. It's kind of the idea of what you were getting at, but now I have it set up that I can use a direct substitution. Don't get me wrong, there are many. I could have multiplied this by 7 and added it
You
together.
can do that if you want to.
Absolutely, absolutely.
Because I don't want to.
And that, there's nothing wrong with that. When it starts to get to these systems of equations, there is really no wrong way to get there. it's what you're comfortable with. If you visualize it and you see it something different, I'm not gonna say no, whatever, it's fine, it's okay. It's perfectly fine. Okay. Jeez, put your foot on this. So we get 7 times the quantity, 13 minus 4z plus 10z is 18. Was it 91, 28,
Oh, wait, where did I mess up?
What's that?
Scroll up.
Yeah. Missed a sign? Please tell me it's 4. I hope it's 4.
Wait, I got.
Because it's easy to get to. Oh. I'm really an idiot. So we have x. Did we find x yet? No, we haven't.
Wait,
Wait.
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 Can you do it like multiplying the bottom by 7?
Multiply the bottom by 7. So you get 7x, 10z, 19, negative 7x, negative 28, and negative 91. Negative 18 is negative 72.
Wait,
X is 4. Z is 4. Sorry, that's supposed to be a Z.
wait, don't the x's cancel out when you multiply by 7?
Yeah.
Yeah.
They did.
So then, and then you get,
Negative 18 is negative 72.
oh, I was just going too fast and like skipping stuff. I was, never mind.
Is that what you got when you did 7? See how it works the same?
Yeah.
It's okay.
I like solved.
No, and that's fine if you don't, it's no big deal. Remember, like I've said before, guys, when we get to this level, I try to show you guys what I think winds up being a little bit more efficient, but I'm not gonna say you can't do something a different way. The only method that I don't want you guys ever to do is the box method for multiplying. Please, yes. Please forget that you ever knew what that meant. Pretty please? Yes. Pretty, that's all I ask. I don't ask for much. I'm not a really big, Alright, so we have 13 minus 4 times 4 is negative 3. What's that? That's that lattice method.
I never knew how to do that.
Good. You're better off. So you have ordered pairs then of negative 3, comma something, and 4. How do we figure out what y is? Substitute back in. Yeah, you just substitute back in that and go from there. Oh, wow, I thought it was like almost over. You're going to find out, guys, they're not difficult. They're just time consuming. So maybe the 6 might turn into a 4. What are you guys getting for y? 2? 2? 2? 2? 2? Yeah, 2 got 8, 2, 2, 2, got 8, got 3, got 3, got 8, 3, got 3, got 4, 4. Hey, I'm more entertaining than Seth. No? Really? I'd be more entertaining than him. I've known that guy forever.
Such a joke.
Not gonna lie, Seth helped me get through college. He's really smart.
Wait,
He's
you guys,
really, really smart.
you guys knew each other in college?
Yeah, that's where we met. Oh, I know.
I got
You're gonna sign it. You can substitute it. Which one did you use? So it's negative 9. Negative 9 and 16 is 7.
Oh, that's where I did. I keep doing that.
Wait, how did you find negative 3? How did you find x?
How to get x?
Oh, never mind. I
X,
said
we had-
it is a wrong here. I put something in for x.
And this is one of the reasons why I go to use that substitution
Yeah.
method, is because then I don't have to screw up that.
Yeah.
That's my own personal thing. We okay? You want to do one more?
We're okay.
All right, let's do this one.
Which one? That's 4.
Oh, I didn't save it. Nuts. All right, let's do this then. Let's go to the page and let's count the number of clicks it takes to get to the book.
1, 2.
Oh. Sorry, I'm not. We'll start over. Hold on, let's start over.
1, 2, 3, 4, 5, 6, 7.
This is not frustrating at all.
8, 9,
All those 10.
10,
These green like 15.
11, 12, 13, 14, 15.
15 clicks is stupid.
I guessed right. 16.
Oh yeah, I'm not even open to the right page yet.
Yeah. 16.
I know I could technically just type in the page number at this point.
Yeah,
Yeah.
and you could just like bookmark that, but then if you're not on like the district Wi-Fi,
Yeah.
then it
It
doesn't
won't
come
let you.
up.
Yeah, you can bookmark it like right here though.
But if you're on the Wi-Fi, then you can just
See, that's good that it works. That'll work, but the fact that it's I'm a very. It should work a specific way, and when it doesn't, I get frustrated. But that's okay. 15 clicks. Yay. So if I read this one through, you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24, and rugby shirts for $36. You want to have twice as many rugby shirts as polo shirts. How many of each shirt should you buy?
You're not getting any
$30
t-shirts.
a shirt.
There was
I know, but it's
Get two for every one.
Mr. Murphy on this one.
Yeah.
It says, I like underlined it. It says the basket will hold at most $300 and $700.
That's why-
maximum number of books. I underlined it. And I said,
No, and that's why I said this one's a little bit weird because there's a different way of setting that one up. But so I don't worry about that one anymore. We don't do that one at all. That's why I say go through that. The other one. So, excuse me. We have 3 shirts. Let's call them A, B, and C. We'll say A, our t-shirt, polo shirt, rugby shirt. I know it's got elbow patches, right? That's the rugby shirt. You want to stock 200 of these. So these are our variables. One of our system of equations is going to be t plus r, or t plus p plus r has to equal how much? 200.
why couldn't you put like less than or? Do you need to sell it?
We stopped 200 shirts.
Because it's telling you this is the difference between the linear programming versus a system. The system ones is going to say how many of each should you have. It's not what combination gives you the maximized profit because you don't know what that function is. This case, it doesn't give you an optimizing function to say, if you were to do this, at least that, how many, it's not asking you for the perfect mixture, it's how many should you have to make this work, this specific parameter. They're telling you what the solution should be, where the intersection of all of them will be. The inverse. Go ahead.
So the next equation you would write would be 12t plus 24p plus 36r equals 6,000.
Yep, that's exactly where I was going. And you were going to say?
That's what I was gonna say.
Very good, very good. And there's one last thing. Hey, here's a big hint, ladies and gentlemen. How many variables are there?
3.
How many equations do you think you should have? Is that a coincidence, do you think?
No.
Yes, ma'am.
Does the second equation have to equal 6,000? Because it's just a flex you don't have to spend on it. Or does it?
In these cases here, you want to spend all of it. I know you're going because we're thinking about what we did yesterday and all that. In this case here, you want to spend everything to stock that all out. And then the last one, you want to have twice as many rugby shirts as polo shirts.
So you need 2r equals 1b.
Do you have enough information now to solve the problem?
Yeah.
Do you see how you're going to use a substitution
Yeah.
for P and
Yeah.
the other two equations, combine them, and then to solve a quick system of equations with two variables? And that's how this works. One suggestion I would do here, though, what would I do with that whole equation before I do anything?
Divided by 12.
Divided by 12. Whenever you have an equation like that that has a GCF to it, take the GCF out. Buy it dinner. Make it feel nice, cozy. Be nice to it.
That's so funny.
So yeah, that's all I would do. I know that it'd be T plus 2R plus R would be 200 then. And then the other one would be T plus 2.
3.
I just haven't gotten that far yet.
Where do you get the first equation?
It's t plus 2r plus.
I just substituted in first. Because 1P is 2R.
But then
I'm just simplifying.
Oh, okay.
And then this-
there should be actually 4r's then.
right.
R equals 3.
And that's 50, right? No, 500. No, wait,
500.
500. I believe that's correct after I simplified out. And then you wind up with T, 3R,
7.
bless you. Oh no, what do you think the easiest thing would be to do here? I am going to suggest take second, subtract first.
Wait, where did you get? Oh, wait, where did you get that? No, it's just. You're talking to 4r's, it's 3r's.
What's half of 300? What's half of that?
75
You need 75 rugby shirts.
which means you need 37.5.
Why did you add t plus 3r?
What's that?
Why did you put t plus 3r?
Because I was going to subtract these together because this is a bigger number than that one. So I just rewrote this. I just rewrote this equation below it. That's all.
Oh, in solves for system of equations?
Yes.
Okay.
I just rewrote the equation because instead of using negatives, it's easier for me just to rewrite and subtract as opposed to multiplying by negatives and have to screw that up. So we have rugby shirts are 75, which means polo shirts would be 150 because you double. I think that was 2R is P. 2R was P. So you double the 75, you get 150. 150 and 150 and 75.
You want to have twice as many.
No, we did not do the whole thing wrong. Why did we do the whole thing wrong?
It would be 5R equals
75 plus
Yeah.
I got R equals 60. I got R equals 60.
What did I screw up?
Because the equation
Oh,
is plus
I can't subtract. No, I did.
No, you can't. It's because it's T plus 2R equals 200, not 3R.
Yeah.
Murphy, isn't it 2P equals R?
But like you add the 2R, 7 and 3.
Did I flip it?
You want to have twice as many.
Oh, I did twice as many rugby.
No, that's right.
No,
That's
twice.
right.
I want twice as many rugby shirts as polo
No,
shirts.
because weren't you just doing the original equation underneath it?
Because then I have T3R is 200.
Oh, that's right. Because then there's another R. That's right.
How did I screw up? X, Y, and Z. Z is, you want twice the number of
No,
polo
I
shirts.
got R equals 75. That's right.
You want twice the number of rugby shirts. You want twice as many rugby shirts.
Wait, why
You
is
double
it-
the polo shirts to equal the rugby shirts. That's what I screwed up. Yep.
So we
You want
need-
twice as many. You have to. All right. So if you have one polo shirt, how many rugby shirts did you have? Two. I wrote it backwards.
Wait, but if you have one polo shirt and 2 rugby, that's right.
In this case, what I accidentally wrote here to start with, I wrote double the rugby to equal the polo.
But it's double the polo to equal the rugby.
Yes, because you want twice as many rugby shirts as polo shirts. I wrote it backwards. Yeah. And then it alleviates our problem. I'm sorry, I disappointed you. And you know what? The reason why I screwed that up, I should have stopped and asked the question, if I double this, will it equal that? And I did not do that. So when it gives you something talking about double or 3 times as many, remember we had that linear programming one where it had the slope going up? And when we stopped, you want three times. If you have one salsa, you multiply it by 3 to make it equal to tomato. I didn't say that out loud here. I didn't say, hey, you want twice as many rugby shirts as polo shirts. So for every rugby shirt,
Wait,
oh,
wouldn't you want twice as many polo shirts for every rugby shirt?
if you have one polo shirt, you want to have twice the polo to equal the rugby, because you want to have two more of them. Excuse me. Yes. Yeah, go ahead. I know. Remember, when we have your rugby shirts, you want to have twice as many of the rugby shirts. So for every polo shirt, you have to double it to equal a rugby shirt.
Yeah, you set up the opposite way.
Did?
Yeah. So you're saying
Can you do the problem how it's
you were like, because it's for every polo shirt, you want double the rugby. The other way around. Why is this confusing? It shouldn't be.
I know it should be, right?
It shouldn't be confusing.
This is why math pain and suffering.
All right, so
Okay.
if I want to have, let's pick a number. If I want 10.
12.
So if I sell 10 polo shirts, how many rugby shirts should I also sell? 20. So you have to double the polo shirt to equal the rugby shirt.
Oh,
Yes.
Yeah.
That's what this says now.
Okay.
Okay?
Because you want twice as many.
I get it now.
And I hastily skipped the step of saying, okay, how many polo shirts do we have? 10. All right, if I want to sell 10 of those, how many rugby should I have? 20. Okay, double the polo shirt. So erase the past 7 minutes. Right?
Okay, yeah, okay, wait, no, okay.
And now we go and do the exact. Now we go. I know it should have been, right? I honestly, I'm not lying to you guys. I have a degree in math. I really do. Whether I use it correctly is beyond me sometimes. Hold on. So I'm going to rewrite this second equation, take out the GCF again. T, 2P, 3R, and we said was 500.
Because R by itself is already double what P is, so then to make an equation, you need to double P.
Yes.
Yes, okay.
So now we go back into it again. T plus P plus 2P is 200.
Wait, how did you get that?
That's the original equation. Wait,
Oh.
Okay. And then I have T plus 2P plus 3 times 2P. Yes, sir. So now
You have to subtract the.
I'm gonna rewrite this equation first because it's gonna be a larger value of P. So I have T 6. Yo. 2 times 3 is 6, right? 6 plus 2 is 8. Just want to make sure I didn't screw that up. And then this is your T, P.
Subtract, you get 5P equals 300 divided by P is 60. You double that, R is 120. You plug that into the original equation, T is 20.
And we math better. And you were right. You know what? Monday, you're in charge. I'm going to sit back there and play backgammon. I don't know. It's the first game that came to mind. I don't even know how to play backgammon. All right, so we're okay getting 60 now.
Cancel it out.
Yeah, because it's, you multiply that.
I subtracted all those. I just didn't write that. I didn't myself. So we have 60 polo shirts.
This job was just like whatever.
So 60 of those, 120 of these, and then 20 of those. So, like I said, I have like 6 of these. I'm going to make it a little bit less because that's a lot of work and a lot of paper. Save a tree or two.
Wait, so, but are we going to see the graphing too?
No.
We're going to graph on the quiz?
On the quiz, yeah, we'll graph, yeah.
Like when we're doing the word problem?
Yeah.
That's when it gets a little tricky.
Yeah.
Yeah, this
On
is-
this one here, I was gonna say, let me see your book. You guys don't have a book. I know I want to cut one. I want to cut one of these out.
Cut 37 out.
This is what 172. All right, go to 34 and then 37. Go 30 through 34 evens and 37.
Wait, is this on the new book or the old?
This is in the new book. I should write that down. In the 15-click piercing. Which means I will do this for you. If you want to wander and take a picture of it, I'll put it up real quick.
Wait, evens and 37?
Evens and 37. 30 through 34, evens and 37.
Can I take a picture of it?
By all means. Let me move it up. Oh, sorry. Oh, sorry.
Change to the
No problem.
So she's at the hospital